Part C.2, average efficiency. Now, in this video, we will do analysis. Mainly, we do the average case analysis. All right. So based on the discussion in the previous video, so this time we will do average case efficiency. Sometimes people also call average case complexity. All right. So let's look at all the cases, because in order to here still, so let's get back to the overall efficiency, right? So overall, in order to look at the overall efficiency, we need to consider all the possible cases. And here from this table, you can see all the cases are here. So it's very easy to find them. So next, we need to use a fair way. Remember, I used this word in the previous video. We need to use a fair way to represent all the cases. What do you mean the fair way? So this weighted average, that will give us a fair way. The weighted, the question is, how do you determine the weights, right? When you look at the weighted average, how do you determine the weights for all the cases? So remember, we have two assumptions related to the probabilities. So those probabilities will be the weights. The probabilities will give us the weights. So we just determine, so figure out for each individual case, what is the weight? All right, so next, another thinking to get a weighted average is we do two-step calculation. So for this question, we do two-step calculation. So why two-step? Because, so if you look at the table here, you can see we have two levels of cases. Two levels, because one level you have hit and miss, right? Hit, miss, two subcases. Subcase average. Hit case and the miss case, right? Miss case, relatively simple. So this is the miss case, relatively simple. But the hit case, you have n subcases and smaller cases. So that's another level of average. So for that reason, we need to do two-step calculation. All right. So within the hit subcase, match subcase, within the hit or match subcase, we calculate the first subaverage. We can call it subaverage. All right. In order to get that subaverage, we, based on our first assumption, we put the probabilities there, 1 over n for each individual case. 1 over n. That's the weights. So we get an average in this way. The usual average. All the numbers adding together divided by the number of cases. And after simplification, we get 1/2 times n plus 1. That's the first subcase. So this number corresponds to the first subcase. For the second subcase, and no match, only one case, so you do not even need to do average, right? You only have one case. So we just take that number, n. Then the weights. Now we look at in order to combine these two subcases, this time two subcases, the hit subcase, the miss subcase. In order to combine these two subcases, we look their probabilities and the weights. The first one, the probability is P based on our second assumption. The second one, 1 minus P. So that means the weights, their corresponding weights are these two numbers. The first one, the second one. Okay, Now we are ready to combine these two subcases and calculate the overall average. All right. Combine two subcase averages based on their probabilities. The weighted average we write in this way. The first sub-average multiply the first weight. The second sub-average multiply the second weight, adding together. All right, that's the answer. Although you can simplify it. Because here, n is the variable. P we treat as constant. P we treat as constant. Okay? So then we can combine the terms. Put the variable in some place, constant, another term. So in that way, after simplification, you can see the variable part 1/2 times n plus 1 minus p, right? So 1/2 times n times p. Remember, there is a p. 1/2 p plus this one, 1 minus p. Okay? So that is 1 minus 1/2. 1 minus 1/2 p times n, then a constant term. So what's the constant term? 1/2 p, right? That's the constant term. Okay, so two terms, the variable term and a constant term. Then I introduce a new concept. Later we will use this concept a lot. So that is called dominant term. In this expression, we have two terms, but the first term dominates all the other terms. So we call the first term the dominant term. So here, you can, when we look at a dominant term, some minor, small numbers we can ignore. So the dominant term, the variable part, some constant number in the parenthesis, 1 minus 1/2 p. So that constant number times variable n. So that is the dominant term. Why we create this concept, dominant term? So the reason is very simple, because later, when we represent the efficiency of an algorithm, we only look at the dominant term. For all the other minor terms, we do not need to consider them. We can drop all the minor terms. We only keep the dominant term. So for that reason, you can see we need to use this concept. All right, so let me stop our second video, C.2, right here.